So building a resilient supply chain for critical raw materials in the telecommunications sector is the topic. And yeah, let's start off the day. First of all, quickly about ourselves. My name is Gloria. I am from Germany and I started joining KPN September this year. And my main focus is on critical raw materials for future technologies.
Hi, I'm Yeji. I'm from South Korea. I also started with Gloria, and right now I'm researching with a focus on how we can achieve circularity of critical raw materials.
Yes, quickly about the content. There are two main parts. The first part is a just realized I'm muted. So the first part is the presentation, which is basically about our research topics and the focus of KPN. And the second part will be a workshop, including brainstorming session, discussion, and closing. So first of all products we are having contain a lot of materials, and some of them are critical. So the first question is, what actually are critical raw materials? And we from KPN, we define that by the European Union, which is firstly, they are of high economic importance to the economy and also are associated with high supply risks. And there are main different reasons for criticality, for example, scarcity risks, which come from physical availabilities in different countries, geopolitical risks, for example, like if there are trade agreements, etc. Demand risks, also environmental risks, like negative environmental implications caused from mining operations, for example, supply chain risks, market risks, also social risks, for example, human rights violations at mining locations. Then how did we do it? How did we come from the beginning to the end of identifying critical raw materials? The first step was to identify our key equipment at KPN. Then we identified the raw material equipment content of this equipment. Then we conducted a criticality assessment to see what of these raw materials can be considered critical. And in the end, we thought about mitigation strategies and how to cope with those different risks. Now, going into more depth, the first and second step, so identification of core equipment and raw material content. For example, you can see a picture of a simplified version of our network. There's, for example, the mobile network with antenna masts. Then there's the fixed network, which is also connected to household service platforms, core network, and, for example, also the internet connected. And from that, we identified the core equipment, like, for example, modems or routers. And another part is our future research, which is basically my main research focus as part of my work at KPN, is to identify as part of strategic importance for KPN, what are the future technologies and how is our future equipment going to look like. For that, I'm focusing on 5G, photonics, quantum technologies, and edge computing, and analyze, what does the future equipment look like? What will replace the current equipment? And what are the raw material content for that? Then the third step, like the heart of everything, was the criticality assessment. We based that on different literatures. There are 4 domains of criticality assessment. Firstly, the economic risk, which is basically vulnerability to supply restrictions and supply risks. Then on the other side, reputational risks, like environmental implications and social implications. And all this was used to kind of answer the questions for KPN, which materials should be prioritized for us, and also where may KPN encounter high risks in their operations. Now a bit more in-depth, how do you really conduct a criticality assessment? And this is only based on the literature KPN used, but there is for sure also other literature available. The first part was to define goal and scope. So firstly, the system at risk. So where are you looking at? Are you looking at a specific product of your industry? Are you looking at the whole sector or components of products? Then what is the objective of the assessment? Do you want to raise awareness of that for your operations, or do you just want to use it to reduce your own risks? And then lastly, the material focus. What materials are you focusing on? For example, cobalt or also rare earth mineral elements, etc. Then the second step was to quantify, according to those 4 domains, the risks, for example, vulnerability to supply restrictions. Indicators in that field could be substitutability, so how easy is it for us to substitute materials that are critical with others? The product value, so in case there would be supply disruptions, how would that affect the value of your product in your industry? Also future demands and the strategic importance for that, which is basically your future technologies, because most likely raw materials might also rise in the future. Yes, and also material value and the spread of utilization, for example. And then supply risk can be, for example, country concentration. So are you sourcing only from a specific location? Depletion time, also substitutability. Also, are you dependent on imports from a specific location or a specific supplier also? What does the recyclability and the recycle rates look like? And how is the demand going to grow? And then lastly, for environmental implications and social implications, environmental is ecosystem quality, for example, which is for example, the impact on climate change categories, etc., and human health, for example, toxicities. Is your the materials you're using associated with health risks? And lastly, social implications, for example, local community, their access to resources from where you're sourcing. Also society-wise, for example, like associated with corruption and workers, like worker rights, child labor, etc. And also down, you can see the sources where we took it from, for more information. This was basically the outcome of what we did and the occurrence in the KPN product. So from number 1 to 4, in how many products were those materials out of the periodic system, which you can see here contained. Exemplarily in 4 products, saying the remote control modem, core router, and plate server, we, for example, use gallium and silicium. Which of course then is of higher risk because we're just using more quantities of them. And then actually the most important step in the end is the mitigation strategy. So how can we cope with the problem that arose from that? So an example is rhodium. The function is the plating of electrical contacts and constituent of capacitors and resistors. We identified that rhodium is really crucial for our equipment, and hotspots here where that it's a companion metal, so it's hardly substitutable with other materials. So, and also it comes 80% from South Africa, where there might be political instabilities or regulations coming. So how do we cope with that? Internally and externally, the economic risk, especially design for reuse, refurbishment, and recyclability. And basically the use of secondary material sources or also substitutions. And systemic-wise, demand-based recycling targets probably throughout the EU, and also, for example, working on trade agreements between countries. And for environmental and social risks, of course, transparency is always one of the main topics, and also to make contracts with suppliers as part of due diligence and source only certified raw materials. And also here, systemic-wise, for example, trade agreements.
Yeah, now I'd like to introduce my research topic on how we are trying to improve the circularity of critical raw materials within KPN's equipment. I'm pretty sure you must be aware of used to the concept of circular economy, where we try to minimize the waste and try to extend and maximize the use of resources that's already within its product life cycle. So until so far, when KPN was working on the goal of material circularity, it was oriented toward mass materials, basically the materials with high volume and high recyclability, such as plastic, aluminum, copper, and iron. However, with the rising concerns on the risk associated with CRM supply chain, and also the result of our product passport analysis showed that actually 30 to 60% of environmental risks of our equipment is associated with printed circuit board, where majority of these CRMs are highly concentrated within. These gave us a huge motivation to expand our material circularity target to the level of critical raw materials. To introduce a bit about how our research approach, then how are we trying to improve the circularity of CRMs? And with this research question, again, the collaboration among our partners along the value chain is really crucial due to the complexity of the component where CRMs are located within, but also due to the complexity of the recycling processes. Therefore, we are trying to reach out to our partners from the both sides of our value chain. We go to the upstream and try to understand the composition of our equipment with the help of our suppliers. And at the same time, we go to downstream to understand where do CRMs flow into and end up at the end of its life cycle. And what we are trying to do here in the end is to bring the suggestions arising from the downstream to the upstream and really exchange those suggestions in between the value chain so that these suggestions can be considered from the beginning of the product design or development process, or even from the beginning of downstream processes. Yeah, so just to give you a better understanding of how circular strategies can be potentially applied to different part of value chain, I brought an example of 3 CRMs, palladium, indium, gallium, which are very commonly used in ICT devices such as smartphone and modem, but also in other electronics. And let's start from taking a look at the value chain then. So first, of course, it starts from material extraction. Usually the primary resources, even nicer if we could use recycled secondary resources. And then the specific component for the equipment or the whole equipment gets manufactured based on the product design planned from the beginning. And the product gets used. It helps for the circularity, of course, if the products get collected end of its use phase. And then at the end of its product life cycle, it goes through multiple process of waste treatment. Then where are these CRMs? Let's look into more details of these informations of CRMs. Usually, most of CRMs are highly concentrated on the printed circuit board within our equipment, especially for palladium. It's situated within capacitors, integrated circuits, and electrode on the PCBs, and indium in LCD panels, and gallium in LEDs or integrated circuits. However, it's really important to notice that the concentration of CRMs in e-waste in the end is very low. Palladium usually have bigger concentration rate. However, in case of indium and gallium, it is in general smaller. And also another thing to notice is that during the treatment processes, especially the pre-treatment processes during shredding, majority of CRMs in the process, which makes it very hard to recover in the end. And also therefore recovery rate, for example, for indium happens to be very low. And at the same time, for in case of gallium, it's very rare for gallium recycling to actually happen at a commercial scale. So, okay. So then let's look at what are some circular strategies that can be considered per each part of value chain. Of course, it would be very nice if secondary materials are used instead of primary materials at the materials production phase, and then designing if the product or component can be designed with in a way these CRMs can be can be recovered or reused in the end. That will be very much helpful for the value chain that happens after this. And it really helps if the company has kind of a system to promote the refurbishment or reuse or resale infrastructure to help the life extension of the product use phase. And in the end, the recycle happens. However, it's also important to notice that these strategies come together with leverage points that we need to tackle with. For example, in terms of secondary material use, often the primary materials are cheaper than secondary materials, which gives less reason for suppliers to choose secondary materials over the primary materials. Also, less reason for the recycler to consider the recovery of these CRMs in the end. And in terms of the design for reuse and refurbishment, it's very hard for service providers or the partners at the later part of the value chain to reach out to the very first tiers of the suppliers to communicate with them how the design can be improved from the beginning. Therefore, collaboration and communicating among different tiers of suppliers are very crucial for this strategy. And of course, take back system or product as a service system will improve the collection rate of the products, which helps the CRM's recovery in the end. And just to lastly mention, as I mentioned, a lot of CRMs gets lost in the pre-treatment processes. For that reason, it's very important for the processors at the end of product life cycle to have a very detailed and meticulous communication with each other, develop and optimize strategies for CRM's recovery. And lastly, I want to mention that these materials, critical raw materials, are not only used for ICT or digital technologies, but are also a crucial part of other industries. So this question of how we can potentially work toward achieving a better circularity of CRMs is a very meaningful and significant topic to think to other industries as well. And for this reason, now I want to open the floor to every participant in this room. So we prepared some questions that we can work on together for brainstorming ideas. First, I will show how we can work on this Miro brainstorming board first, and then we will share the link via which you can enter this board. So I hope you can see my screen. So this is the board that we are going to work on together today. I'm going to first give instructions, and then we are going to start leaving some introduction and 3 questions. And let's start from the first slide. As soon as you enter this link, please make sure that you click my name at the top right side of the screen. Then you'll be able to follow my cursor and follow how I'm navigating you through the different slides. If you click somewhere else, then you will lose the track of my where I am. However, if you want to keep following me, you can always come back and click my name icon here. And in terms of how to answer the questions, if you look at the left side of the screen, there's a sticky note. And here you can just choose whichever color you want, and then you click and drop. But please make sure that you leave your name and organization while leaving an answer, because we are planning to develop and make a report out of results, which we want to share with you. It's very important for us to understand which partner in what part of value chain really emphasizes on certain aspects. So please make sure to leave your name and organization, and please leave one answer per sticky note. And it's also easier for you if you copy and paste this sticky note, so you don't need to write your name and organization all the time. And there is a designated time for each question, and I'll guide you to the next question once the time is up. And if you ever get lost on where we are, you can go to the left bottom side and click this double arrow. Then there's this first, click this first icon, frames. Then you can navigate through the, you can see a nice arrangement of our questions, which will help you navigate. So please use this function if you ever get lost. And then now let's enter this board and work on this together. Gloria will share the link in the chat, but please make sure not to use the Internet Explorer, please use Chrome, Firefox, or Opera, because Internet Explorer does not really work well with this platform. Thank you. I see people entering in. I will bring everyone to, yeah. Yes, I hope you can see my cursor and where we are. I'm going to give a few more seconds so everyone can join. Wow, I see many people. Oh. Bart, do you need? I will deny this because I'm presenting at the moment. Okay. Okay, I will then now start with explaining the very first exercise. Basically, we want to know who is in the room. So if you are ready, please go take your sticky notes here and please drop notes. I prepared a block indicating different work areas from design, manufacturing, R&D, smelting, service providers, and please leave your sticky note where it corresponds to your work area. You can always drag and move the sticky note if you want. You can also adjust the size. We will have about 2 minutes for this. Also, if you have a problem working with this board, please leave a question in the chat, or if you don't hear from us, please also feel free to use your mic. Also, if you're coming from university as students, you can put your sticky notes under research and development. Okay, I see everyone is pretty much done. So if you have hard time leaving a sticky note, I can show it again. You can go to the left side of the screen, then you can choose your sticky note. And yeah. Oops. Now we are going to move on to okay, I will now move on to the first question due to the time. If you haven't finished the first exercise, please take a little bit of your time. Okay. I hope you're following me. Okay, so this is the first question. You can scroll down a little bit and you can find your first question. My first question for you is that what are the drivers or barriers to you when you try to work toward the goal of circularity of CRMs? What makes you what drives you to work toward this goal of achieving circular use of critical raw materials? Or what makes you hesitant, or what makes it difficult for you to work to achieve this goal? Please leave your answers. We have about 5 minutes for this activity. And I see that most of people are leaving their name and organization on the post-it, which is very nice. Thank you very much. Okay, we will have about 30 more seconds and then we are going to move to the next question. Okay, really great to see a lot of answers. Now we are going to move on to the next question. If you are not still working on the first question, please don't worry and follow us. You can scroll down and you can find the next question all together. I already see a nice answer on the question too. Yeah. And please move on to the next question in the below. Then our second question is, as I mentioned, the collaboration is very important to achieve the circular use of critical materials. And then how do you think we can enhance this collaboration among supply chain partners? I've left some diagram depicting the whole value chain. Please leave your answer that corresponds to the work area. For example, I left an answer communication between OEM and component manufacturers, then it's situated between component manufacturer and OEM. Yeah, please leave your answer that corresponds at the location that corresponds to it. We will have about 4 minutes to answer this question. Okay. Okay, we are going to move on to the next question in 20 seconds. Okay, let's move on to the next question. Yes, I already see some people working on the last slide. It's about our mitigation strategies. Then what do you think for building a supply chain resilience of critical raw materials? What do you think are the actions that are necessary to be taken today to mitigate the supply chain risk for your future technologies? There are 3 types of answers that you can leave. Internal strategies we can take within organization, or external strategies we can implement between different parties or companies, or in a systemic level. Do you think there should be a more investment policy level regulations, or any different type of system level support with better technologies? Yes, please feel free to leave your answers. We are going to have the last 6 minutes, 5 to 6 minutes for this, and then we are going to move on to discussion. So in case you are lost, I'm going to just bring everyone to the last question, if that helps. I will bring everyone to where I am looking at. Yeah, so this is where we are working on. Just lastly, I want to again mention, ask to please leave your name on the post-it. Okay, we will have one last minute, and then we are going to move on to the discussion. Okay, I think everyone's pretty much done. Then let's move back to our first activity, and I will bring everyone to me. So we are looking at the same place. Let's see briefly who is in the room. I see a lot of people joining from product design. Very happy to hear that, because design also is very, very important aspect of value chain. I see people joining from product manufacturing, R&D, also from smelting and refining. Nice. And also other people from other industries. Great. Then let's move on to our first question. Let's start our discussion. So it's very nice to see a lot of different answers. Actually, one thing that grabbed my attention were some, oh, okay, that's about the barriers, but yes, that working toward the circularity of critical raw materials drive some competitive, competitive advantage advantage to the service provider. The answer from Micah, I think this is also a very good point. And I see that a lot of ethical standards and limited resources that gives a legitimacy to working toward the goal. And yes, Florence mentioned about new recycling technologies like hydrometallurgy, biometallurgy, which is actually available in the scientific level, but not very much scaled to commercial level frequently yet. So there's room for development. I want to actually now start discussing the barriers, because I have some points to mention together. I saw that Bram mentioned about not getting paid for, yes, Bram from Blue Engineering mentioned about clients do not pay for this goal in the projects we are hired to perform. Bram, are you there? Can you elaborate a little bit more on what you answered here? Yeah. Hello? I can't hear you yet.
Hello.
Yes, I can hear you.
I clicked mute twice.
Great.
Yeah, so we are a small company and we don't make our own products. So we are an engineering company and we make designs. And our clients typically have questions about functionality. And to take into account recycling or critical raw materials is something that is deeply involved in the mission of our company.
Yeah.
But our clients do not want to pay us to take extra time for that, to incorporate those things.
I see. Then do you also get to design components such as PCBs where CRMs are highly concentrated on?
Yes, we make lots of electronic products with sensors on them and printed circuit boards, but we only have a limited budget to make a functional product. And yeah, we are very dependent on clients to do some extra work.
Wow, great that you pointed out this economic drivers, because that's really, really important. I can see that from business perspective, but then I have two questions. Then do you ever get any client who is very mindful about the circularity of critical materials? And secondly, how much, like, does it really require a lot more budget to take this circularity aspect into your design?
So in the first question, we are very looking very hard for these specific clients with these profiles. But sadly, no, not 100% of our clients are motivated to. They have an environmental policy, but they are not in the top sustainable companies.
Okay.
So yeah, maybe 1 in 10 of our clients actually has requirements regarding recycling or environmental issues.
Yeah.
And for the second part, yeah, one big problem for us is that not everyone is trained. So people need information, they need knowledge, they need experience, and then it has to be applied in some practical way to the thing we are designing. And most information that's available is quite broad and vague, and it doesn't really apply to the resistor that you are designing right now.
I see.
It simply takes people time to incorporate the information and the strategies into what they are actually doing.
Yeah.
And we are mostly paid per hour, so
Yeah,
that's where the high cost comes from.
I see. Yeah, I see. Very nice. Maybe we can also catch up on that part later, further on. Thank you for sharing your insights, and also as Bram just mentioned, I think understanding of the components really in detail, I think that's the key. And I actually have some question in terms of barrier to any manufacturing companies that's participating here. Have you ever had a communication with the different preceding tiers of your suppliers to understand the components that you are purchasing from the component manufacturers? Is there any OEM manufacturing company joining here? I guess not.
Can you rephrase your question again?
Yeah. So I was wondering if any manufacturing companies, OEM, has ever tried to communicate with the component manufacturers to understand the CRMs and the detailed composition within the components they purchase.
Yeah, I think it's a pretty difficult one. There is now a research proposal written. KPN is also involved in that circular circuits that more or less addresses this. And well, the writers of the research proposal circular circuits like NXP, Signify, ASML, etc. So big companies, they more or less think that this has not yet been done. I think the example that you gave from KPN is quite a good one. The way you not pressure, but invite your chain partners to collaborate with you in further development, and also tell you if it's possible or not, and what their ideas are, without in the first place telling that it shouldn't cost more, or that it should be cheaper, or but that the aim is to become more sustainable. I think that is the first aim. And a second and also a healthy aim is that you say, well, let it be more sustainable and not more expensive. That's a good goal to work on together. And maybe it's a bit more expensive, but whatever. There was, I think it's more or less been answered, but there was also a question in the chat from Daan de Kruijf. What obstacles do you face during implementation of circular strategies? And then concerning, that was more or less mentioned by the speaker before, are there specific skills, training, etc. missing with employees if you want to move towards circular?
That's really good question. Is this a question to KPN or I think this question? Yeah.
Yeah, if you have an answer, and also, otherwise I can answer it a bit from UPCM.
Yeah. Could you answer, because I think this applies more to manufacturers.
Yeah, in my opinion, there is a need for more training, other skills within this. If you look at the EU Circular Action Plan, there now is something like the right to repair, and how that will be implemented is not yet 100% clear. But if it is implemented, we will need different kinds of skills with people to be able to handle these kind of repair questions, and to make sure that it is done in a certified way, that it is safe, that if a repair company handles a KPN or whatever product, that is still safe to use. So these are specific also technical skills, maybe enhanced or helped by digitization skills. So there's a lot to do, I guess, in training skills, etc. So that's a good question of Daan de Kruijf, who I believe is also working on that. If I look at this next item, learning for tomorrow is next to his name.
Yeah, I agree. There's a lot of more trainings or digitization, advanced technologies needed for repair side, also from the manufacturing side. Because of the time, I will move on to the next questions. But it's very nice to see here diverse answers regarding the complexity of PCBs, and also a lot of different requirements for regarding economic and business model factors. Okay, let's move on to the next question. I see a lot of answers, which is nice. And I see especially a lot of answers from the material extraction, product and product design development. I also, also what we just mentioned from Bram, I see an answer about make training available for engineers is very crucial. My question here is that does anyone want to share, have a really burning desire to share some of your answer on how we can leverage the collaboration, or does anyone have any suggestion from the policy and regulation perspective?
Yeah, from policy and regulation, I do think that there could be something like a more common language. And I have a nice example from Philips, who did this on vacuum cleaners, for example, on reusing plastics. That together with other vacuum cleaner companies, they joined forces and said, well, if we have this kind of plastics recycled quality, we can use it again in new vacuum cleaners. So that's developing together more an industry standard. And on these kind of topics, work together with even competitors in the real life, but partners on sustainability. And I believe KPN is also active in those kind of how do you call it, telecommunications companies or suppliers towards the telecom sector.
Yeah, these the standardization, I think that's a very good point. I hope there is someone joining from the policy and regulation side can take this suggestion into consideration. And because of the time, we actually need to move to the next question. Gloria, would you like to discuss some points that's mentioned here?
Yes, just to quickly summarize, for the internal, there were a lot about strategic importance, and also included to the board of management strategies, for example, or include CRMs and circularity assessments. For external, what, for example, came to my mind, what I thought was really interesting was product lifecycle management has to be digitalized in a good process to extend the life of hardware internally. I was wondering, Laura, maybe if you would like to speak up and say, how could you imagine that the product lifecycle management would be digitalized? What would be needed for that? And would that be part kind of like a network together? Or like, yeah, if you want, you can elaborate a bit on that.
Yeah. Yeah, it's quite complex product lifecycle management, but yeah, I can imagine that for your company, you have to digitalize at least what kind of products are in the field and all different kinds of aspects on these products, like the materials incorporated, which can be taken out, or maybe parts that could be replaced in a certain amount of time to upgrade it. It's a quite a difficult digital question to, yeah, how to arrange that, because I don't know much about your situation, and there's a lot of different kinds of data you can store about a product. Yeah. So yeah, I cannot answer that in 1 minute. It's
no. Yeah, thank you.
Yeah,
thank you
but
still.
The solution for when you manage your life cycle of a product, well, you know when to have to take it back or when to refurbish it, and you can facilitate the whole circular process instead of getting demand out of the market by your customers. It makes sure you are in control and you can plan ahead. What to do when. So
yes. Yeah, thank you. That's really interesting insights, and also for me, at least, a new insight on to make it more digital. And also, as last, just to quickly summarize, for the systemic level, there was developed industry standards, new ones to comply with regulations and go beyond sustainability and SDGs, or also make more funding available and subsidies to parties. Also the total chain of electronic waste and the recycling and rewinning of raw materials should be improved and created much faster, and also encourage substitution. Due to the time, I think we have to stop at this point because our workshop is over. Still, thanks a lot for all the input you gave. Thanks a lot for the interesting insights and also the knowledge exchange on this point. It would, of course, be great also for really helpful for us and interesting to further communicate on all these topics and maybe also build a network for knowledge exchange. Therefore, if you would like to know more, besides us sending the report about this to you, you can always reach out to either myself or Yeji and ask questions or just schedule a meeting about to learn more and exchange knowledge. So thanks a lot for participating, and hope to talk to you soon at some point.
Thank you very much. Hi, Florence. Oh, you're muted.
Yeah, I see it. Yes.
Yeah.
Thanks again for a good workshop.
Thank you for an active participation.
Yes, but that was arranged by UPCM, so it was on purpose that I was also active here.
I see.
But I think it was a good workshop. I think you did a great job also by using this Miro tool. That is a great tool. Yeah. And what I hope is that people take away the methodology that you use at KPN, how to make these steps towards circularity, to make it a strategic issue, to make it a structured way of thinking, a structured way of working, so that you more or less analyze what's in our products, what is the value chain for those products, who do I need to make the change happening. This approach was, to me at least, really impressing over the past year. And I hope we have inspired other companies more or less to copy it.
Yeah.
And to use even maybe even the slide setup of the way you did it, and to show what kind of materials from this Mendeleev table are in my products, and what is then a simple product to start with, what are my more complex products, these kind of questions. So let's see what comes out of that, and let's hope that we see one or more of your KPN methodology slides pop up at other companies with maybe some different colors, but the same methodology. So that's great.
Yeah. So.
All right. Well, thank you for all the preparation, and have a great weekend.
Thank you. It's weekend. Yeah, thank you very much for joining and for all the sharing the tips and knowledge today. And I hope to talk to you soon. And weekend. Have a nice Friday.
All right. Bye-bye.